let's start. Okay, so 8.1. Now remember that we did not take chapter 7 test. Try to do some problems in between from chapter 7 so that you guys don't forget that factoring skills. All right? Okay. Okay. So 8.1. Those who are going to write down the notes with me right now, you guys start from, write the title, 8.1, which is graphing f of x is equal to ax squared. Looks like this entire chapter is about graphing quadratic functions, but in different format. We're going to start with the very basic one, which is f of x is equal to ax squared. Okay, so let me make this a little bit bigger. Okay, first of all, what is a quadratic function? A quadratic function is a non-linear function. It's not a line. The graph is not a line. That can be written in the standard form. Y is equal to ax squared plus bx plus c. Are you guys familiar with that ax squared plus bx plus c in the factoring lessons we learned in chapter 7?
Yeah.
Yeah, so you know that the quadratic function looks like ax squared plus bx plus c. Now today and the rest of the few days, we are going to look how are we going to graph these quadratic functions. Okay, now, so do you guys see this like the graph under the title characteristics of quadratic functions? So this U-shaped graph is the graph of any quadratic function, this U-shaped graph right here. Okay. This one right here is called a parabola. And that's the graph of any quadratic function. And we're going to talk about the characteristics of this. We're going to talk about the characteristics of this parabola. Okay. So every parabola has a vertex right here. Do you guys see the vertex? This is the vertex. And then there is a dashed line through the vertex, which is called the axis of symmetry. So the dashed line through the vertex is called the axis of symmetry. The axis of symmetry divides the parabola into two equal parts. Do you see that the axis of parabola, the axis of symmetry cuts the parabola into two parts, equal parts. So on one side of the half of the parabola, you see that the function, the red one, is actually decreasing from here. It keeps decreasing, and it stops at the vertex. And then from there, it's a turning point. It changes its direction. So a vertex is also called the turning point, where it changes its direction. So from here, it's now increasing. So this part is the decreasing part. This part is the increasing.
All right. I'll go look at it. Oh, yeah, okay, here it is.
Hello? Okay, so the decreasing part and then the increasing part, and the vertex seem to be just like halfway through that, and that's called this turning point. In your notes, you'll see that the vertex of the parabola is the turning point, or the lowest point or the highest point on the parabola that opens up and down. You will see later on that some parabolas open up and some actually open down. But either way, vertex is called the turning point where it changes its direction. Is that clear?
Yeah.
Yes. All right.
Yes.
Okay. One more time. What is the standard form of a quadratic equation?
Y equals ax squared plus bx plus c.
Correct. What do you call the shape of the graph?
Parabola.
Parabola. How does it look like?
A U-shape.
A U-shaped. And if the question asks for the characteristics, there are a few things you guys are going to tell me. What about the characteristics? You're going to tell me what the vertex is. In this case, the vertex happened to be 0, 0, the origin. Right? You will also tell me what is the axis of symmetry. Look at this axis of symmetry. Is that a horizontal line or a vertical line?
Vertical. It's a
vertical line. So the equation is going to be x is equal to 0. That's the axis of symmetry, because axis of symmetry is always a line. And hence, you guys have to give me an equation for that. Clear? Mm-hmm. Okay. Now let's fill out these things. It says that the axis of symmetry is the vertical line that divides a parabola into two symmetrical parts and passes through the vertex. The axis of symmetry of the parent function y is equal to x squared is x is equal to 0. You also have to fill in one thing right here. The vertex of the parent function is at 0, 0. Are there any questions so far? Are you guys good?
Yeah.
Yes. All right, okay. Let's try example number 1. Identify the characteristics of the quadratic function and its graph. Okay. First, we have to identify the vertex. Now, everyone think about it. What is the definition for the vertex? It's the lowest point or the highest point on a U-shaped parabola. It is also the point where it changes its direction. So what is the vertex in this example number 1? Does it look like this point right here?
2, -2.
Does it look like this point, everyone?
Yes.
Right. So the vertex is going to be 3, negative 2. So the vertex is 3, negative 2. Let's look at what is the axis of symmetry. Axis of symmetry is always the line that passes through the vertex. Passes through the vertex. So that seems like a vertical line. So the equation should start with x is equal to
What?
3.
Yeah, I do.
X is equal to 3. The domain for a quadratic function is always all real numbers. All real numbers. Because you can take anything. So you see that you can take 1, you can go this way. It just looks like it's cut right here, but it's actually not. It continues forever on both directions. So the domain is all real numbers. What about the range?
The range.
What's the
All
range?
real numbers.
You see that range, we don't have anything below this point. You see that?
Yeah.
Correct. So it's
-2 or higher.
everything, correct. It's everything above that point. This point right here is -2. So you would write the range as everything greater than or equal to -2. Question so far?
Nope.
Are we good? Okay. Now increasing. Where is the function increasing? You see that the function is increasing from here all the way up, right? Increasing. Do you see the function is increasing from here up?
Mhm.
So you're right. Okay, sorry. Okay, what did I do?
Stuck.
How do I go from, okay, got it, okay. So increasing, the function is increasing when, yeah, go ahead, when x is equal to greater than 3.
3.
And function is decreasing when x is less than 3.
I want to watch 2012 too. Watch it.
Is it clear?
Yeah.
Yes.
Okay, Amrita, do you have a question?
No.
Okay. So just look at example one more time and see if you clearly understand what all the questions are. Are there any questions?
No.
No.
No. Very good. Okay. Now, since look at example 2. We are asked to graph each function. I have 4 of these examples right here, and you have to compare that with the parent function y is equal to x squared.
Oh my gosh.
Since we did not graph y is equal to x squared, I don't have the space for that right here. Why don't we graph y is equal to x squared, which is the parent function? This is the parent function. Let's graph that somewhere. I'm just going to pull out another sheet. And then let's say here. Okay. I want everyone to graph y is equal to x squared. which is the parent function. Okay, let's make table of values, x comma y. Let's take -2, -1, 0, 1, and 2 for x. And y value is going to be -2 squared, which is 4, -1 squared, which is
1,
0,
0,
1.
1.
Okay, and 2 is 4. Now let's graph the function. I didn't like that, so let's. Okay, so -2, -1, -2, 0, 1, and 2. -2 corresponds to, let's say, 1, 3, and 4. -2 corresponds to 4. -1 corresponds to just 1. 0 corresponds to 0. This corresponds to 1. This corresponds to 4. And it continues. It doesn't mean that it stops at those 2 points, okay? This is going to continue. You guys just connect them. Get it? So this is the graph of y is equal to x squared, which is the parent function of any quadratic function. Okay. Now let's go back to our first example. This is our first example. Look at this. Okay. Why don't you guys make a table of values for this one? Meanwhile, I'm going to graph my parent function here so you can compare. Okay. You guys just make a table of values for example 1. Now let's make the table of values x comma y, -2, -1, 0, 1, and 2. The y value is going to be 0.5 times -2 squared, which is what?
2.
2, that's correct. 2. And then when -1, it's going to be 0.5 times -1 squared, which is?
0.5.
Zero it is.
0.
1 it's going to be.
Half.
And 2 it is.
2.
2. Okay, now plot the new points, new set of points, and then graph on, for example, graph for example number 1. Hey, okay. -2, it's actually 2 this time. Let's take green. Now look at my new graph, which is 0.5x squared. Did you all get that graph?
Yeah.
Yeah.
Okay.
Yeah.
Now I want you guys to compare with the parent function. The parent function is the red one. That's why I drew it on the same graph paper. If you guys want, you can do the same thing. So the red one is the parent function. Green one is the new one, which is 0.5x squared. Does it look like like, how do you want to describe that transformation? It looks like something happened to our parent function, right? Parent function is x squared. It looks like I simply multiplied the parent function by 0.5. And look what happened to the graph. This is one of the transformations we learned earlier. Which one do you, bless you. Which one do you think this is?
It's stretched.
It's stretched, right? Now you have to figure out, is it stretched vertically or horizontally?
Horizontal.
It looked like a horizontal stretch, but we also learned that horizontal stretch is also same as a vertical shrink, right? If you think about, if you take the original graph, which is your red one, and then try to shrink vertically, do you think the red graph will become more fatter and wider? If you shrink vertically,
Yeah.
right? Does it look like the green graph is vertically shrinked by 0.5?
Yeah.
Okay, so that is what I want you guys to write, because when you simply multiply the function by a k, that's always vertical, stretch, or shrink. Okay, when the function looks like y is equal to kx, but you can write this down somewhere. When the function looks like y is equal to kx squared, there is a vertical stretch or shrink happening to your parent function. Now, how do you decide if it is a stretch or a shrink?
It will be a shrink if the at k is less than 1. It will be a stretch if it's more than 1.
Correct. Very good. So then you look at the k, right? What is the value of k in this example? In this example, k is equal to 1/2, correct?
Yeah.
Okay, that's less than 1. That is why it looked like a shrink. When the k is greater than 1, it's going to look like a stretch.
So it's going to become more narrow.
It's going to become, it's going to be more narrower, very, very close to the y-axis. That is what a vertical stretch means.
Okay.
Is that clear, Jasmine?
Yeah.
Okay, all right. So it also says compared to the parent function. So I want you guys to write next to the problem. You can say that the new function is a vertical shrink by 1/2. New graph is a vertical shrink by 1/2. Are there any questions?
No.
Okay, now we are going to move to the next problem, B. Yeah, let's make the table of values again here. X, Y. Let's take the same x values, -1, -2, 0, 1, and 2. Fill out the values for y. Fill out the values for y. Y is going to be, when it is -2, it's going to be 2 times -2 squared, which is
8.
8. That's correct. Plot the points. Can I plot this on the same one so you guys can see whether it's a shrink or stretch?
Sure.
All right. Which color do you guys want?
Purple.
Okay. All right. Plot the points. When it is -2, it is 2. Sorry, no, it's 8. I did a mistake in the red. Why did I go with 8 first? 1 second. Did you guys did not, I plot the red one a little wrong. I was thinking 2x squared in my mind. 1 second, I have to make a small change. My red one was, I'm erasing my red one because I made a little mistake. Oh, all of them are gone. Okay, sorry. You guys plot on your own. I will fix it soon. And red one was my original one. This is -2. And then it is then I used the green one for this one, which is -2 is just 2. Okay, now I'm going to do this. -2 is actually 8 all the way somewhere here. And then it is 2, 1 is just, -1 is just 2. Okay, so now I have all 3 graphs on the same graph paper, so you guys can actually compare. Okay, which one is the purple one?
The 2x squared.
Correct, 2x squared. Okay, so the red one is y is equal to x squared, which is the parent function. The green one is our 0.5x squared, which is like a wider one. And then we have the purple one, which is 2x squared, which look like much steeper and very close to the y-axis, correct?
Yeah.
Okay, now we are going to compare that with the parent function. How would you compare the purple one with the red one? There is a number attached to the x squared, which is 2. So is that a vertical stretch or a shrink?
Vertical stretch.
Vertical stretch. So we are going to compare this function coming back to y is equal to 2x squared. You're going to write it is a vertical stretch by the factor of 2. It's a vertical stretch. It is vertical stretch by a factor of 2. Clear?
Mm-hmm.
Yes.
Okay. Now I'm not going to draw any more here. I think then that's going to be hard for you guys to see. Let's graph C and see what's happening. The only difference between A and C is, what's the difference between A and C?
It's negative.
There's a negative in front of it. Let's see what's going to happen. Do you guys want to guess what happens?
It's going to flip.
Gonna flip it. Yes, exactly. That's correct. Let's still make a table of values and then figure out -2, -1, 0, 1, and 2. So the y values are -2.
Negative half.
Very good.
0, negative half.
Negative half again?
Yeah.
Mm-hmm.
Negative 2.
Correct. It's repeating, right? Yeah. Let's plot the points. -2 is actually -2 this time. And -1 is actually -1/2, 0 here and here.
Okay, and you finish your homework already? Finish it.
Okay. So does it look like what you expected? Did you guys say that it's going to be flipped?
Yeah.
Yes. Alina, tell me, it's flipped across the y-axis or x-axis?
X, I think.
X-axis. It's flipped across the x-axis. Okay. So if there is a negative in front of it, that just tells you that it's a reflection, write it down, across the x-axis. That negative right here, that negative right here means there is a reflection across the x-axis. Mm-hmm. Joel, I can't hear you properly, so louder, please. Yeah, so again, it's kind of unclear to me, but then I think I know what you're asking. So if you go back and read the direction the very first time, it says you have to compare it to the parent function, right? So how would you compare this one, your question C? There is a negative in front. There is also 0.5, which means we are talking about two types of transformations here. The first one is you're going to write there is a reflection across the x-axis. And the second one is vertical shrink. Very good. Rutika, I think. No? Who said that, Prusha? Vertical shrink by half. Okay. Here we go. So we are talking about two different transformations of that problem. Why? Because it is not just x squared. There is a negative there. You took care of it by saying it's a reflection. There is a 0.5 there, and you took care of it saying that it's a vertical shrink by half. Is it all clear?
Yes.
All right. D. Question D. Let's do the XY thing again. -2, -1, 0, 1, and 2. You already have the 2x squared. Just flip the signs then. Plot the points. Oops. Okay, write down the two transformations. First one is still the same thing, a reflection across the x-axis. And then this time it's a 2, right? Which is greater than 1, so it's going to be a vertical stretch by 2, right? Because it's a 2. The negative is already taken care by the reflection. Now you just look at the number without the sign, which is a 2. So since it's greater than 1, it's a vertical stretch. So 2 transformations. Okay, now let's go to the last section of this lesson. Lessons are pretty short, so which is good. You guys can take plenty of time to understand stuff. Okay, now let's see what does this actually mean. Whatever we discussed right now is summarized in this, the last part of the lesson. Do you see that? The green one, the blue one is the original parent function. So write it down next to that. The blue one is the parent function, x squared. Green one is any stretch. Green one is any stretch. And red one is because when a is less than 1, that's a shrink. So if it is narrower and like longer, stretched vertically, the factor will be greater than 1. If it looks far away from the y-axis, which means it looks wider, that's going to be a shrink. All about vertical shrink. Okay, now let's see, we need to fill out some things here. When your a, which is the number in front of the x squared, is less than 1, the graph is a, write down, vertical shrink. Vertical shrink. When a is greater than 1, the graph is a vertical stretch. The first one is a vertical shrink. The second one is a vertical stretch. Moving to the right side, what is it when it is a negative?
Reflection.
Yeah, reflection. I think it will be confusing if you just fill out this. The negative can be just taken care by the reflection. Is that okay? Because I don't want you guys to get confused between the negative and the value of a. So I think I'm just going to skip this. It's okay. You just know that when there is a negative in front of it, it's a reflection. I think that part is clear to you.
Yeah.
Is that correct? Okay.
Yeah.
So that's the lesson for today. Do you guys have any questions?
Can you go back to A and B?
Yeah. This is our A, but I have all three on that. So A is, what is your question about A? Oh, you just wanted to see it?
Yeah, sorry. Yeah, I just wanted to see it.
No problem.
And B?
And B is,
He's on it.
oh, I did B in the purple color on the first one.
Oh, okay.
Yeah,
All right,
my
okay.
purple. The reason I did all three on the first one to show that how it is, how it's steeper and how it's wider.
Okay. So
All
for the
Mhm.
range in example 1,
Mm-hmm.
just where it stops and how tall it gets.
Correct, and it's going up, so you will just look. Yeah, let me show you. Okay, no. Where do I get the laser thingy? Oh, right. Okay, here. Jasmine, you asked this, right?
Yeah.
Okay, so Jasmine, see that this is the vertex right here,
Mm-hmm.
right? Okay, so you see that there is nothing below that point.
Yeah.
So you look at the y coordinate of this, which is -2, and say that y is greater than or equal to -2. See? That's how you decide the range.
What is the axis of symmetry?
Axis of symmetry is this dashed line that passes through the vertex. Axis of symmetry is the one that divides the graph into two equal parts. So axis of symmetry is the line. So I'm going to write the axis of symmetry is x is equal to 3 because it's a vertical line.
Okay.
Right? It's a vertical line that divides the graph into two equal parts, and this is the equation. Do you guys want to do one more problem like that then?
Yeah.
Okay, so
Yes.
I don't have it here, but I'm going to read it out for you. Let me take the textbook. Okay, 1 second. So this is 8.1. Hey, if you guys want to upload the homework on a daily basis to Google Classroom, go ahead. I don't want you guys to procrastinate everything and keep it for the last day whenever we are meeting. So if you feel like it's going to motivate you to do the homework daily purpose, if I make it due that day and turn it in, then please go ahead and turn it in Google Classroom or School Loop. Either one is fine. I think let's stick to Google Classroom then, so that I just need to only look at one place.
Do we turn in the homework? Do we take a picture of it and then like turn it into Google?
Yeah, that's fine. But I want to see the name.
Are you gonna create like an assignment like for each one, and then we can all turn it into that one?
In Google Classroom?
Yeah.
Okay, then hold on to it. Let me do that first, and then I'll let you guys know when you can start turning it. Okay?
So far, we've only had 3, right?
So far, I gave you one Monday, one Tuesday, and today is, 3.
Do it like at the end of each week. So like you just make one assignment, and then you can turn in all of the weeks.
Okay, yeah. So
Alright.
I'll do that. Yeah, I'll do that. Even Google Classroom is kind of new to me. I have never used it, but then I'll let you guys know once I'm ready with that assignment so you can turn it in, okay?
Yeah. So we just take a picture?
Yeah, take a picture, but I want to see your name also.
Okay.
Or otherwise you'll have to scan the whole thing. I don't know. Like, let me see. Let me think about it.
Into on Google Classroom because you'll see our names.
Okay.
So I think it'll be fun.
Okay, write down the question then. The extra question that you guys want to do.
Okay.
Okay, I will write down the question here then. Okay, so the graph.
What is this a graph for?
Yeah, so I think the direction is going to be exactly same as example number 1. Okay, if you guys have the handout, just, or otherwise I can scroll up to that point, but let me finish the graph first. I'm going to give you the graph. You have to write all the characteristics. That's the question. And then 2 is kind of, dang it. Okay. Now the direction is going to be, graph is given to you. Identify the characteristics. Identify the characteristics of the quadratic function. What is that?
I have no idea.
What happened, Alina?
Lena.
Oh my god, what was that?
Oh, scary.
Spider?
And no siblings.
Okay.
Sorry.
All right. So I gave you guys a graph. You guys have to identify all the characteristics. When I say characteristics, I want you guys to start with vertex. What is a vertex? From what do you understand from my graph?
And -1.
1, comma, -1. That's correct. The next thing is axis of symmetry.
1. X equals 1.
Very good, because it has to be a line, okay? So you have to tell me like an equation. You cannot tell me 1. You have to say x is equal to 1. This is the axis of symmetry. Ding, 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 ding. Yeah. Next thing is you have to tell me the domain.
All real numbers.
Correct. All real numbers. Oops. Range. Range means y, so you start with y. And unlike all other graphs, this one is actually opening down,
Less than -1?
which is fine. Yeah, so you say y is less than or equal to negative 1. Because we don't have anything above -1, so y is less than or equal to -1. The next thing is, tell me where is it increasing? The function is increasing. Now watch, I'm going to point that. Everyone look at the screen. Yeah, it's increasing here. You see that? Up to here. It's increasing from here all the way up to there. So you're going to say that it's increasing when your x is less than -1. Sorry, not -1, +1. To the left of -1, it is and decreasing when x is
Greater than 1.
greater than 1. So this is what I mean by characteristics, okay? You're going to write the vertex, axis of symmetry, domain, range, increasing, decreasing. So 1, 2, 3, 4, 5, 6. 6, where did it go? 6 characteristics. Are there any questions?
No.
Yeah. No.
Are we good with 8.1?
Yes.
So I think I already posted the homework for today, right?
Yeah.
Okay, so do that. Now we are done with the lesson. Look at all the lecture notes, do those problems, keep it in your binder, or just once I fix the assignment for this week or something, you can upload that there. Until then, hold on to it. And then I'm also going to do one thing. All this video recording, as well as the writing that I have, the lecture notes, will be posted in Google Classroom today itself. So when you do the homework problems, if you have any questions, you can either refer back to my video, like, watch it again if you want, or just look at only the PDF of the lecture notes that I'm going to post. So you have 2 more things to refer back to, even when we are done with the lesson.
Yeah.
I think that's good enough.
Mm-hmm.
Yes?
Yes.
Okay.
Okay. So then, all right then. I'll see you guys tomorrow at the same time.
Okay. Bye.
Okay.
Okay,
Tomorrow
bye.
from 2
Thank
to 3.
you.
Okay. Yeah. Bye. Thank you.
Bye.
I'll see you guys tomorrow. Take care.
Okay,
Okay.
thank you.
Mhm,
Bye.
you're welcome.